Okay, this is the first part. I consider about the mathematical formula representing the Bayesian inference. And the second part, after we obtain the BN model, so I'd like to classify, okay, the relationship between the node into three cases. It actually has more than three cases, but I like to focus on the three. This is my work. So there is a single inference, joint inference, and the mixed joint inference. On the single inference, we have the one parent node and one child node. Okay, and a parent node has a single positive or negative inference on the child node. If in the first case, if the parent node invested in project A has a single positive inference on a child node entire project process, okay, the first inequality equation was derived. Probability of the entire project profit given investment in the project A, okay, must be greater or equal than probability of the entire project profit given by not invested in project A. And in the second case, if the parent node has a single negative inference on the child node, okay, this equation can be used. This is the first case. In every BN model, okay, we can see the situation like the joint inference. In this example, I select a case study that the reliability of the people and the future income and the age has an impact on the credit worthiness. So, but you can observe that if the people have higher reliability, they also have a higher credit worthiness. If the people have a very high future income, okay, or have a chance to get a higher future income, okay, their credit worthiness is higher. Okay, in this joint inference here, the parent node here have a single positive inference on the child node. Okay, and we derive the equation in equality equation like this. For example, let me talk about the first equation. Like probability of the credit worthiness given reliability, future income, and age must be greater than or equal to the probability of the credit worthiness given by reliability and future income is inactive and age is inactive. Okay, we set the case and we put the probability value into the table and we perform the Bayesian updating and we try to observe. Okay, and we try to derive the inequality equation. This case. And the last case, mixed joint inference, means that the one parent node has a single positive inference on child node, and another parent node has a negative inference on the child node. This one has positive, this one has negative. Okay, we try to play with the data, put the data into the model and perform the Bayesian updating. Okay, after that we try to derive the equation. Okay, we come to the conclusion. In this paper, I propose a methodology to use the qualitative expert knowledge. Like we ask the expert that if we have a variable A and B, and A should affect B, or B should affect A, or B and A have no relationship between them, and we take this as an argument we call the omega, and we put the omega into the Bayesian equation. Okay, and we focus more on the Bayesian inference in the Bayesian network, and we also establish the decision-making assumptions and the general equation for the Bayesian inference based on data and knowledge obtained from the expert. Okay. The next, a detailed method to transfer knowledge, represented by a set of the qualitative statements. Okay. into a high distribution for the Bayesian probabilistic model. Okay. In the second part of my paper, I proposed several cases for Bayesian inference and the probability inequality constraint presented in each case. And my future work based on this study, we intend to apply the Bayesian network inference with the qualitative expert knowledge. I try to extend to other areas like group decision making, and we try to collect the group decision knowledge and we apply to the Bayesian inference to try to find out the solution for group decision based on the Bayesian network, especially for Bayesian inference. Okay, that is all for my presentation.
Any question?
It sounded like you were using actual things like income numbers rather than probabilities.
Yeah, actually, it will come up in the term of the probability value at the final stage. But at this turn, I try to formulate the mathematical equation representing the Bayesian inference by thinking of the non-numeric knowledge that we obtain from experts, and we try to find out what the mathematical formula should look like when we include the non-numeric expert knowledge. But at the final stage, it will come up with a probability value that experts say that they agree that A course B, but just 80% they are sure, something like that. Okay, this is very this is my first stage for this topic.
Thank you for the question. The next talk is about Mr. K. Chan.